The next phase is the development phase, and there we use the detailed design to be able to encode and move the system towards the final product. Now, the key activities performed in the development environment can be things like creating system-level documents, debugging and testing of the code, possibly converting old data to the new system's data, creating procedures to be able to handle the transition to the new system, making sure we make for training of this new product to the end users, and documenting all of the modifications. Now remember, this is a development, right? We are making it. We aren't deploying it out there yet, but we're talking about, as a part of the development, because during the development we're going to know how things are working. We should know how the old system, if there was one, was working, so that during this phase we're also making plans for the later deployment, right? Converting old data to new data. Creating procedures, as I said, to make a transition. So we'll get to talk about some of those, especially when we get into the deployment, the implementation. But it's something we started off early in this process rather than waiting till it was done and already out. In the development phase, you should have documentation to list the type of programming methods and techniques that are being used. That should include your source code documentation, data declarations, construction and techniques that you use for input and output. And I have to tell you that at one point in my life I wanted to be a programmer. Now I also have to tell you this goes all the way back to 1983 that I wanted to be a programmer. Today is a lot different than it was. I don't want to think how many years ago it was. Too many years ago. But one thing that was the same was source code documentation. The professors told us that we'll never get above a C no matter how brilliant our code was if there was no documentation. So that meant that 2 letter grades depended on how well I could document the source code. And often they meant in line with the actual where we're typing the code to put in our own REM statements. And let me tell you, it was a very complex. In fact, it was not unusual for the finished product of code, if it was, let's say, 100 lines of code, for me to have a 500-line, what looked like a set of code. 400 of those lines were source code documentation. Now, I have to tell you that later on, it made sense to me because if I needed to do an upgrade to this program, and it's been 6-7 months since I worked on it, I'm thinking I'm going to forget some of those details. But the more information I put into the documentation, the easier it was for me to understand what each piece of code was doing. Now, we also have today stuff we didn't have back then. Integrated development environments, or what we call the IDE. Now, that's a technique that we borrowed from online programming that helps aid the development of the end product. In fact, a lot of the IDEs, some of the most popular ones we see today is from Microsoft. Visual Basic, C#. They are solutions that they also, by the way, use in what they call the rapid application development, but we haven't talked about that yet. But as an integrated development environment, what it does is it brings up this great screen that I can create code from, some of it graphically. I mean, if I want a code to make a form that's going to pop up, or to make a web page look a certain way, I can literally click and drag out the shape of the form, click and drag these controls onto the form. It develops for me the back-end code to draw that screen, and I haven't had to type anything. And if I need that particular object or control to connect to a database in the back end, that's where we're integrated right into that environment. And it really does help speed up application development. Again, but that's another part of the development phase. You might be using some of these types of tools, which would still have source code, don't get me wrong, but it's, it feels different than our traditional C, C++, Java types of design. Now, the developer should document, as I said, the type of programming languages that were used. As an example, it might be what we call a high-level language, such as C or COBOL, for those of you who want to go way back. Whether or not we used an object-oriented language, such as C++ or Java. If we used any of the IDEs, like Visual Studio, which is what we called the Visual Basic C# together, because it also does ASP.NET stuff, Visual Studio, or JBuilder. Maybe we're using pure HTML or scripting languages. You could even be one of those hardcore, just uber smart programmers, and you're using low-level assemblers. And yes, I remember that was one of the programming languages I originally had to start with, was assembly language. Today we have fourth generation languages. We call them 4GLs, high-level programming languages like database management. SQL, the structured query language, is an example of a high-level program that we use in being able to work with a database management system. Database management systems you'll always see as DBMS. During the development, we said we should be doing debugging. Debugging should be done during this phase as well as the documentation, and that documentation should include the type of debugging programs that were used. Now, there are several types of debugging tools. They fall in three categories. They could be the logic path monitors, which follow a sequence of events. Okay, and that's what it does, right? You type in the code, and you type the code in sequentially. That doesn't mean it executes sequentially, because in coding, we can always jump to another procedure or another function and come back, but we're going to follow that path and see where you're going. In fact, we used to do this a lot in those early days of the 80s, because we were, basically graded on how much recursion we had to use. Because the idea of recursion is that it used up more system processes and memory, which we didn't have a lot of back then. And and recursion was you follow a statement and then it calls something, and that program calls the original caller, and now we're kind of in a loop. And at some point, we hope you broke that loop. But that's what we do. We're going to follow a sequence of events. Look at that logic. Memory dumps. Memory dumps allow you to view the internal memory contents at any point of time. So as this program's running, and you're saying, there's just something wrong. It's not processing information right. You do a memory dump, and you can look at the memory contents and say, oh, somehow this information got written into the memory wrong. Now we can look at it. Output analyzers can check the output for execution accuracy, meaning that we know what input we gave and what the expected output was, right? So we can do comparisons. Your testing should be documented, as well as the type of testing process that's used. Now, there are a couple of different testing processes that you might find. Some things like the test plan can be developed early on in the life cycle and may be constantly revised until the actual testing phase. Your test plan should categorize the types of deficiencies that might be found during the test. Another one is the bottom-up testing, and that's considered testing of the atomic units, such as programs or modules. Now, especially in an object-oriented programming, we do create these tiny snippets of code. Sometimes we call them functions or procedures, or depending on the programming language. And it could be other components too. Distributed component object model would use things like DLLs and XEs as little independent modules. And there are things that might be called, but you start the program at the top, and as you're running through the program, then you call these modules. Well, bottom up is you're testing those modules first at the bottom and then moving your way up. And the top-down testing is similar, right? We start at the top. We just, go through, and then when it calls a module, we'll test it. So either way, you have some options as far as the methods by which you might go through in testing the software. Now, regardless of the testing classification that's used, IT approaches to testing might be based on the size and the complexity of the system. That means you might have to modify the system to include testing, such as unit testing, which is the testing of each of the individual programmed modules. Interface or integration testing, which is where hardware or software tests might be made to evaluate the connection of two or more components and how well they pass information. And that is important, right? Because let's say you're using a barcode scanner. That's a piece of hardware, but there's a module on the other side that has to be able to run it, read it, do something with it. We might want to look at how those two work together. It could also be two software components that are talking to each other as well, passing information back and forth, whether on the same machine or not. Your system testing, which would be a series of tests against the entire solution to be able to check for proper functionality. And finally, you have the final acceptance testing. And that should be done at the conclusion of all the other testing, but before the general release of the solution. In the final testing, there should be some form of quality assurance that's going to be applied. Now, there are two major parts of the final acceptance testings, and that is the QAT, the quality assurance testing, which is going to focus on the technical aspects of the application, and the UAT, or the user acceptance testing, to see which basically focuses on the functional aspect of the application. The UAT is going to ensure that a system is production ready, right? If the users are happy and they sign off on it, then we're ready for production. Now, the testing should be formed in a secure testing or staging environment like a lab. And what that means is that we don't want to test in live production. We want to simulate live production and make sure all is well before we put it out into the live world. After the acceptance testing is done, your final step usually is certification and the accreditation process. And this process can help in the final decision for the point of business application. Now, there are some other types of testing, many you've probably heard of, like the alpha and beta testing. Right? Those are the things we do before we go gold with the product, where we have people try to beat up the software and find problems. Might have a pilot testing where maybe we have a gold product, but we're going to release it to a limited number of people, let them actually work with it, see how it runs. White box testing means that you're testing this because knowing how this program is supposed to work, and trying to follow the normal way in which you're supposed to use it. A black box testing means you are approaching it as though you have no idea about the processes and what's supposed to happen with this application or system. And the idea here is that you might, because you don't know what it's expecting, try to put in erroneous information or bad information, but that's good testing too. The function or validation testing, making sure that it's doing things right, that you get out the results you expect. Regression testing. Now, regression testing is not for a new system, but if I'm about to make improvements and updates, I often want to make sure that those new updates are going to be able to work with the old methods or the old data as well, right? So it's kind of a regression testing. We can do parallel testing, where I have many people working on this thing in the testing realm. Sociability testing, it goes back to people's thoughts about it. I mean, I remember seeing lots of ads when Windows 7 was first coming out, and people saying, I can't believe it's Windows 7 because look how great, and blah, 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 all those marketing things. But that's a valid test, right, to get that kind of consumer or user feedback.